All right, let's just jump right in. We're going to talk about gravity. You know, that thing that keeps our feet on the ground. We feel it every second of our lives, but what if everything we think we know about it is wrong?
Seriously, what if it's not a pull at all? What if even Einstein's brilliant idea of spacetime being warped like a bowling ball on a trampoline is just a hint at something way weirder, something almost digital?
Yep, lag. The same kind of slowdown you get when your computer is trying to do too many things at once. It's a wild idea, but it's the heart of a totally new way of looking at how the universe actually works.
So to really get this, you have to kind of reboot your brain. Stop thinking of the universe as empty space with stuff in it. Instead, picture it as this gigantic computer that is constantly, and I mean constantly, running a program to create reality itself.
Look, for more than 100 years, we've had Einstein's general relativity, and it's been amazing. It says that mass tells space how to curve, and that curve tells things how to move. And it works. The math is perfect. But this new idea doesn't challenge the math. It asks a much deeper question. Why does it work that way in the first place?
So, if the universe is a computer, it must have some basic rules, right? Like an operating system. So let's forget about geometry and curved space for a minute, and instead, let's think about processing power.
Okay, don't get hung up on all the symbols and equations here. Just focus on the main idea. It's actually super simple. The universe has a limited amount of processing power to exist. And everything in it, all matter, all energy, is constantly using up that power.
So here's rule number 1. The universe's total computational power is fixed. It's a limited resource. Think of it like your computer's CPU. There's only so much of it to go around. You can move that power from one task to another, but you can't just make more out of thin air.
And rule number 2 changes how we think about stuff. Mass isn't just a passive lump. In this new model, mass is an incredibly complicated piece of data. It's like a really demanding app that's always running in the background, hogging a ton of the system's resources, just to maintain its own existence.
And this brings us to rule 3, and this one is a mind-bender. What we call time is just the universe's processing speed, its clock rate. So in parts of the universe with a lot of spare processing power, the simulation runs really fast. But in areas that are bogged down processing a lot of mass, the simulation slows way down. Time itself actually ticks slower.
Okay, so we've got our 3 rules. Limited power, mass hogs that power, and time is processing speed. Now, this is where it gets really, really cool. Because once you accept those rules, some of the biggest puzzles in physics suddenly start to make a whole lot of sense.
Let's talk about time dilation. It's a proven fact. Your GPS has to account for it. Clocks in orbit literally tick faster than clocks down here on Earth. Why? In this model, it's not because spacetime is curved. It's just CPU lag. Earth is a massive object consuming local processing power, so the clock speed of reality itself is slower down here. It's that simple.
And it's the exact same logic for why starlight bends around the sun. In Einstein's view, light is following a curve in space. But in this view, light, which is just information, is trying to find the quickest path. It's avoiding the laggy zone right next to the sun and taking a detour through the faster, computationally clearer space around it. It's like data packets on the internet looking for the fastest server.
So, what happens if you push this system to the absolute brink? Well, first, you get a ton of mass packed into one tiny spot. That mass starts consuming more and more and more of the local processing power, until eventually there's absolutely none left. And what happens when a computer runs out of resources? The system crashes. That's a black hole. It's not a place with infinite density. It's a localized blue screen of death for the universe. It's a region where the computer has hit 100% CPU usage, and reality itself just stops. There's no processing power left to even calculate the next moment, let alone let light escape.
Now, this all sounds pretty wild, I know. But the big question is, how does this radical new idea hold up against the reigning champion of physics for the last century, Albert Einstein himself?
So let's put them head to head. On one side, you have Einstein's view. Reality is geometric. Mass creates curves, and everything follows those curves. On the other side, you have the computational view. Reality is about resource management. Mass creates lag, and everything follows the path of least lag. 2 totally different ways of describing the same phenomena. And here is the most critical, most absolutely essential point to understand. This isn't about proving Einstein wrong. It can't, because for every single observation we've ever made, The math from this computational theory spits out the exact same answer as general relativity. The what happens is the same. This theory just gives us a completely different why.
In fact, you can basically create a direct translation guide between the two. What Einstein called spacetime curvature becomes a gradient in computational power. What he called a black hole event horizon becomes a computational singularity, or CPU at 100%. The physics doesn't change, just the language we use to explain it.
So you might be asking, if the math is the same, what's the big deal? Why bother with a new interpretation? Well, because this new language lets us ask some really exciting new questions. Thinking of the universe as a computer suddenly gives us new tools. For instance, could that weird quantum fuzziness just be the universe's resolution limit, like the pixels on a screen? Could dark matter not be stuff at all, but maybe some kind of computational artifact or shadow? It opens up whole new avenues of thought. But it all boils down to this one really powerful idea. Gravity isn't some mysterious force or a bend in geometry. It's just the visible side effect of the universe's limited computer reshuffling its processing power to deal with the heavy data load we call matter. And that, of course, leaves us with one final, pretty unsettling question. If our entire reality is computed into existence moment by moment, and gravity is just cosmic lag, then what does that make us? Thanks for tuning in.